In this video, we're going to talk about tuples, or tuples, you can say it either way, which are just like lists, except they're immutable, meaning you can't change them once you assign them. That's not as big a limitation as you think, because that's the way strings work. They're also immutable. So you can store strings inside tuples, or numbers, pretty much anything. And you can do just about everything you can do to a list, you can do with a tuple. So here we're going to find the 0th element. That's going to print the number 3. Now let me run this. It's going to print 3. You can find the length of the tuple, and that'll be 2 because there's a 3 and a 5. That's 2 elements long. You can use the plus operator to concatenate 2 tuples, and I didn't print a longer tuple. Yes, I did. I printed it out. So let's look at that. Yeah, it concatenated 1, 2, and 9, 8 to make a tuple which has 4 integers in it. You can slice tuples just like you can slice lists. This, if you remember, will start at the beginning, go to the end. Actually, it's -1, so it starts at the end and goes to the beginning, and it prints it out backwards. So instead of 1, 2, 9, 8, it goes 8, 9, 2, 1. You can loop over tuples. It means in a for loop, this will print each one of the elements of a tuple one at a time. So that's a 1, 2, 9, 8. That's a 1, 2, 9, 8. And you can use functions on tuples as well, and this will find the maximum item in the tuple. So again, the difference between the tuple and the list is that the tuple is immutable, so these will not work. You cannot assign the first element, the element at index 1, to be 25. That works on a list. This would not work on a string, for example. It doesn't work on a tuple. You can't append to a tuple. When we concatenated 2 things, we were actually assigning it to a new variable, so you can't just change the first one and append something else onto it. Tuples don't actually require parentheses. So if you just have 9, 10, that's a tuple. So if I run this implied tuple is going to show up like it's a tuple, because it is. And this is kind of how things have been working behind the scenes when we said that you can do multiple assignments. Like, for example, we have a coordinate pair as another tuple, and you can unpack it, meaning that you can let me show you how this looks like. What you're used to seeing. We're used to seeing things like this, where you can say, well, yeah, you can assign 2 different things on one line. And really what's happening is this is a tuple, and it's unpacked. So x would be 46, y would be 23. And you could do the same thing with a tuple explicitly. So like coordinate pair is really an element with an item with something with 2 items, and so it puts the first item 3 there, second item 5 there. So that's unpacking a tuple. The same concept has also been what's been happening behind the scenes in a function when you return 2 items. So here we're returning, you enter a number, it returns the number after it and the number before it. So there you go. So this returns 2 things, and it's actually returning 1 thing. Every function returns 1 element, 1 item, and it is and 1 object. In this case, it's a tuple. So it printed before and after was, oops, I put the equals in the wrong sign. So before and after is a tuple. We've been using it so that when you call a function before and after like this, we've usually been unpacking it right away. But this is so that'll get B and A into separate variables. But actually, you don't need to. You can keep it in a tuple and work with it from there. So when you're returning multiple, what you think are multiple objects, you're really returning 1 object, and that's a tuple. And likewise, you can use a tuple to import to input different elements. So here we're importing math, we're finding the angle given an x and a y, so it uses an inverse tangent. Oh, by the way, you guys should be familiar with inverse tangent too. Atan is a function that only returns angles in quadrants 1 and 4. Atan 2 extends that idea and returns angles in all the different quadrants. Pretty handy. But anyway, if you have a point and you want to stick the coordinates of that point in for x and y, you would hope that you could just put that point as a tuple inside angle and call it. But point really is one object. And when it assigns it, it'll assign it to the variable x, that one object point. And so it won't really split it up. It won't split it up as you go. So this will give an error message because it's only entering one parameter in the function call when the function's asking for 2 parameters. But you can unpack point by putting this asterisk there. So what the asterisk does is it says unpack point, and when it makes the call, so then it'll have 2 different things. It'll put x in for 3, y in for 8, and it'll work. The other way to do it is a little more straightforward, but is just, is a little bit clumsier. I could call it this way. I could say, well, I have the point, the x coordinate is in point with the index of 0, and the y coordinate's a point with index of 1. This will work just fine. And it'll work the same way. Okay? And it's just that sometimes it's nicer just to work with, like this is one of the main uses of tuples, and what I use tuples for is things where the position matters. Like the first position is always the x coordinate. The second position is always the the y coordinate. And like you don't want to accidentally sort this and make the x and y wrong. So the position matters. I use a tuple, and sometimes it's handier just to keep things in tuples. And like instead of having this have 4 parameters, like the slope, you need the x1, y1, x2, y2. That's fine, but maybe you can just have the slope take 2 different points. You can unpack it inside your function definition and calculate the slope and return y2 minus y1 over x2 minus x1. One really nice feature of Python is that comparison operators work with tuples and lists. So if you want to know which one's greater, the tuple 1, 9 or 2, 3, it sorts it pretty much how you'd expect. It looks at the first item in the tuple, and 1 is less than 2, so this is going to be true. If there were a tie, let's run this and I'll show you. Oh, I forgot a bracket. Give me a second. Actually, it wasn't an unmatched parentheses. It was the fact that I was using the same inside a double quote. You should have single quotes, at least in Python version 3.11. 3.12, this is fine inside an F string. But anyway, let me run that again. 1, 9 was less than 2, 3. That's true. But if it was a tie, the first one element is the same, and then it looks at the second element and realizes this will be false because 3 is smaller than 1. So on a tie, it looks at the second element. It does the same thing with lists, which is really nice. And you can even sort, let's say here's a list of tuples. And and we can sort a whole list, and there it puts the smallest element, which is 2, 5 first, and so forth. Really powerful and really awesome.